In this video, we're going to take a look at SpectralDeNoise. Now, where the denoise module worked well with a varying noise floor, SpectralDeNoise works really well with noise that is constant. With this, we can use the constant noise to build up a noise profile with the SpectralDeNoise and use the parameters to reduce the noise. So it's always handy to have a sort of top and tail of the noise that you can select. For example, I'm going to use two examples. This is a guitar that I've recorded. I also used a guitar sample for the guitar amp denoise module, but I've recorded using a different mic that's got a constant noise over here. You can hear it here as well. And then also there's the sound sample that we used for the dehum module, which has this constant hum. And we're going to see how much of that we can remove with the SpectralDeNoise module. So what you need to do, as you can see, is no noise profile has been made on the SpectralDeNoise module. What you need to do is first select a area and then click Learn, and it builds up a noise profile for you. If you don't have a big enough area to learn, then you might need to zoom up and find areas to select. So you could select an area, hold down Shift, maybe if you wanted to grab another gap of an area, and then you can click Learn and it'll create a noise profile for you. But luckily, we've got an area that we can select. I'm just going to zoom out and learn the noise profile again. For now, I'm just going to close the Advanced Settings tab. We'll get to that in a bit later in the video. And I just want to focus on the parameters you see here. So like in the denoise module, you've got a threshold, so you can set where that threshold point is and adjust how much of the information you want in the denoising. And then there's also a reduction, where you can specify how much of the noise you want to reduce. Then down here, you've got quality settings. Obviously, the fast setting at A is going to be the least CPU intensive, but as you move up, you're going to get a better quality, but it is going to have a higher demand on the CPU. Also to note, if you're using this within a plugin, only option A of the quality is available to you, where in the standalone, you've got B, C, and D. Obviously, D being the best quality. Let's start off with A, and then we'll check out the other qualities. Then you've also got artifact control. So if you take this and move this to the left, it's going to be more accurate at removing the noise, but it can bring in that sort of underwater goggle sound and introduce some artifacts. If you find that is happening, you're probably going to need to back off a bit and move over to the gate side. So starting off from here, let's take a look at those settings. I'm going to first play through this guitar amp, and you can hear this buzz over here. Now I'm going to select and preview it using these settings. Bring up the reduction. Listen over here. Make more musical noise. That's working well. You can hear this was before. And then now. Working really well. Now let's go over to the dehum. I'm going to learn the profile. So selecting the front end of the audio, learning the profile. We've got the profile here. And let's jump up this quality to maybe C and then preview it. I'm going to select a section of the audio and preview. This is an example of some hum in the audio, which could possibly be this. You're listening closely. Some hum in the audio, which could possibly, you can hear that. So I'm just going to play before. This is an example of some hum in the audio. Now I'm going to select all of this, preview it, and then adjust the musical noise and the gating. This is an example of some hum in the audio, which could possibly be from a grounding issue. This is an example of some hum in the audio. Now, just to show you an example of this musical noise and gating, I'm going to bring up another audio example, but it's not going to be very good showing you how it denoises, but it will show you the difference between that sort of gargly sound and the gated sound. So this is the D-Wind audio sample. I'm going to select the first bit, learn the noise profile, and then I'm going to select everything, and I'm going to preview and switch between musical noise and gating, and hear how you get that sort of gargly sound here, and as I back off to gating, it backs off on that sort of artifacty water gargly sound. Here recording a signal where there's some wind. We're going to see if we can remove some of that wind and how much of it can be removed. Pull down the reduction. Here recording a signal where there's some wind. We're going to see if we can remove some of that wind and how much of it can be removed. So I'm not too sure if you heard that there, but as I was over on the musical noise side, it was sounding gargly. As I moved over to gating, it cleared that up. So that's just an example of this artifact control. Now let's take a look at adaptive mode, and then we'll move over onto the advanced settings. So now let's take a look at adaptive mode. With the adaptive mode, you don't need to learn the noise profile. When you click adaptive, it's going to learn the noise as it plays through the audio. And you can set the sort of learn time or sort of buffer where it'll decide how much of that time the denoise is going to use to adapt to the changing noise profile. So if I play back, you're going to see this graph change and move as it's adapting. So I'll preview it. Change the threshold point. Now, with this amp, it's using a tonal noise. If you go over here, you can sort of de-link the threshold and the reduction, and you can choose how much of the noisy component you want to set the threshold for and how you want to set the threshold for the tonal. Also, you can decide how much of each you want to reduce. So let's say with the tonal, we want to increase the threshold for that and reduce the noisy. And then for the reduction of the tonal, we want to increase that. Let's make a selection and preview it. If I did the reverse and increased the noisy threshold and went and pushed up the reduction of the noisy, you would get a completely different result. Check this out. So that's adapting while it's learning and changing the noise profile, but it's picking up the tonal noise. So that's not very a good judge for this audio example. But I just wanted to show you the differences between the noisy and the tonal, between the threshold and the reduction. Now next up, I want to talk about this curve. So I'm just going to go out of adaptive mode, learn that noise profile again, and then enable the curve. What this allows you to do is create a reduction curve where you can draw in node points over here and smooth out the curve. I just want to do something here. I want to select this beginning noise, hold down shift and select that as well and click learn again. So we've got this noise profile, and at this point it is quite high. I can create some node points and bring this down. And what I'm doing is smoothing off the residential noise profile. And my goal is to get the residual noise line as smooth as possible. So this is the noise profile, this is the residual noise, and we're trying to smooth that off. There's another peak over here. I could click here and bring that down, and maybe also do a slight drop over here. Then over here, you can smooth that out to have a more natural curve. Now let's talk about these advanced settings. First off, we've got algorithm behavior. Here you can smooth the algorithm that is being used and the FFT size. This is using multi-resolution. If I untick this, I can specify the FFT size I want to use. Just note though that if you're not in adaptive mode, if you change this FFT size, you'll need to relearn the noise profile. But basically, with a higher FFT size, you're going to have more bands to get in between those harmonics of the sound and the noise, where with the lower setting, it'll react faster and tend to be more pleasing. But you can also tick this multi-resolution, where it'll do all the thinking for you on what FFT size to use. Then synthesis. This is going to re-synthesize the higher frequency partials to improve the brightness of the result. So for example, if I go to this D-hum module, I'm going to learn the noise profile. Then I'm going to preview it back. This is an example of some hum in the audio. Now, if I increase that synthesis to improve the higher frequency partials, this is an example of some hum in the audio. You can hear there's some higher frequency content from the resynthesis. The enhancement is also going to predict and enhance those partials. This is an example of some hum in the audio, which could possibly be. This is an example of some hum in the audio. Masking uses the psychoacoustic masking to only reduce the audible noise and keep the inaudible noise. Now, it's recommended to keep this at 10, but you can try adjusting this to see if it's having any change on the noise from a psychoacoustic level. Then with whitening, the resulting noise floor can be made to sound closer to white noise or to the original noise. This is an example of some hum in the audio, which could possibly be. This is an example of some hum in the audio. If I click output noise only, you'll hear the noise that's being reduced, and then we can switch between the left and the right to hear how that's changing the sound. You can also see how that's adjusting the residual noise. Now let's preview the output noise only. And then you also have a knee. So with this knee, you can decide when the noise hits a threshold, do you want it to kick in right away or do you want it to be more gradual? You can also see how that changes the noise profile. As I increase that, it smooths it out. Then there's also a release. So the release can bring this up to reduce the musical noise, and it can also affect the transients and the tails. So just check if you need a shorter release or a longer release on the sounds. So that covers the spectral denoise module. It's quite a big one compared to just the denoise, where you've got to learn the profile, you've got different curves, you can change the curve behavior, smooth things off with algorithm behaviors, and even change the way that the noise floor is working with the synthesis, enhancement, masking, and whitening. And the most important thing is this works well with constant noise. So if you've got a sound with a noise that's very constant, then definitely have spectral denoise as your first module of call before going to the denoise. Now let's check out some other modules. Catch you in the next video.